In this video, we'll be going over the spring final review for Algebra 2. Let's begin. For numbers 1 and 2, I want to, for each angle, find the nearest positive and negative coterminal angles. So what that means is, coterminal, I want to find an angle that starts and ends at the same spot that 221 degrees does. Meaning, I'll be adding and subtracting a full circle in order to find another angle that ends at the same location. So in degrees, 221 degrees, I'm going to be adding 360 degrees. So 221 plus 360, that's going to be 581 degrees. This is coterminal to 221 degrees. To find something that's negative, we're going to start with 221 degrees again, but this time, let's subtract a full circle. So I'm going to subtract 360 degrees. So 221 minus 360, this is going to be negative 139 degrees. Now I want to do that same thing for 4 pi over 5. Now this is going to be in radians though. In radians, a full circle is 2 pi. But if I try to do 4 pi over 5 and then I add 2 pi to it, that's not going to work out. Because in order to add these together, I'm going to need fractions with common denominators. Well, 2 pi, if I've got a denominator of 5, I can just multiply this by 5 over 5. So 2 pi is really the same as 10 pi over 5. Now I can go ahead and add these together. That's going to be 14 pi on top over 5. I'll do the same thing here, but subtract. So 4 pi over 5, let's subtract 10 pi over 5. That's going to give me negative 6 pi over 5. For numbers 3, 4, 5, and 6, we'll be doing some conversions. I want to convert each angle measure from degrees to radians or from radians to degrees. If I do the left side here, I've got some degree measures. 41 degrees converts to what radians, and negative 246 degrees converts to what radians. Well, let's start with what we have. 41 degrees and negative 246 degrees. What I want to do is I want to multiply by pi over 180 degrees. The reason for this is pi and 180 degrees are the same. They're both halfway around a circle. I actually got this from 2 pi is the same as 360 degrees, and then I just simplified that to pi over 180. But since these are the same, I'm really multiplying by 1. And of course, multiplying by 1 means everything's going to stay the same. The value of it's going to stay the same. Now, this being a special one, I'm going to change the way that this looks, but I'm not necessarily going to change the value of what we have. So 41 degrees times pi over 180 degrees. Ignore the pi for now and do 41 divided by 180. Now, you'll get some decimal here, 0.22777. Okay? But if you hit math, enter, and then enter, to make this a fraction again, this will be 41 over 180. So this looks like this doesn't reduce. So 41, let me do that in black here, 41 pi over 180 radians. All right, next, negative 246. Divide that by 180, ignoring this pi for now. Now this will reduce since these are both even numbers. We've got negative 1.36 repeating here. So let's do math, enter, enter, and I'll get negative 41 over 30. So this is negative 41, put your pi back in, over 30. Now to go from radians to degrees, again, start with what you have. So 9 pi over 17 and 5 pi over 7. But this time, I'm going to go the other way. Instead of multiplying by pi over 180, I'm going to multiply by 180 degrees over pi. We'll see here that pi's divide out. And what I'm left with is 9 times 180 divided by 17. I can go ahead and just do that in my calculator. 9 times 180 divided by 17. So this first one will be 95.3 degrees. Then I've got 5 times 180 divided by 7. So this is 128.6 degrees. Okay, 7, 8, 9, 10, 11, and 12. Evaluate each trigonometric function without the use of a calculator. So when you see without the use of a calculator, that means use your unit circle. So let's do the left side here, since these are all in degrees, and then after that, we can do the right side, which are in radians. So here's a reminder of how to use your unit circle. If it says sine of 60 degrees, you're first going to find where 60 degrees is on your unit circle. That's right here. And then that has a point 1/2 square root of 3 over 2. Well, the cosine of this angle measure is this x value. The sine of this angle measure is this y value. And the tangent of this angle measure, I've written that on the outside here. That's sine over cosine, sine divided by cosine. So when I say sine of 60 degrees, it's really saying, what is the y value of 60 degrees? Let's square root of 3 over 2. Cosine of 210 degrees. So find 210 degrees. That's right here. And the cosine is the x value. So that's negative square root of 3 over 2. And the tangent of 120. So we'll find 120 right here. Tangent is negative square root of 3. All right, that takes care of the degrees. Let's move this over. And let's do the radians. Sine of pi over 4. So now I'm looking at the radian measures. Pi over 4, same as 45 degrees. The sine is square root of 2 over 2. Cosine of 5 pi over 3. So let's see, 5 pi over 3 is right here. And the cosine is 1/2. And then the tangent of 5 pi over 6. Okay, 5 pi over 6 is right here. The tangent is negative square root of 3 over 3. Okay, the next section, 13 through 18, says evaluate these trig functions with the use of a calculator. So here you're going to have to be really careful. We've got some problems, the left three, 13, 15, and 17. These are in degrees, and the right three, 14, 16, and 18. These are in radians. So you have to be really careful as to what mode your calculator is in. Right now I'm in radians. I kind of like doing the degrees first, so I'm going to change my calculator's mode. To do that, I'm going to hit mode. I'm going to go down to where it says radian or degree, and I'm going to use my arrows to highlight the one that I want. So I'm going to highlight degree, hit enter, and you'll see at the top right, this changed to degree. So I can clear this menu. If it stayed degree, then you know that you are in degrees. So now I can just go ahead and do sine of 77. 0.974. Here we'll go to maybe 3 digits after the decimal point. We'll do cosine of 198. This is negative 0.951. Tangent of 73 degrees is 3.271. Rounding that 0 up because of the 8 after it. And now I'm ready to do my radian measures. So I have to go back in the calculator's mode. Right now I'm in degrees. I want to go mode, go down to radian. Once I've highlighted that, hit enter. And again, you'll notice in the top right, this changes to radian. Go ahead and clear, make sure it stays radian. Okay, we're good there. And then now let's go ahead and put these in. Sine of 2 pi over 7. So 2, to get pi, hit second, and then this caret. So 2 pi over 7. This is 0.782. Cosine of 9 pi over 5. So cosine 9, second, and the caret to get the pi, over 5. This is 0.809. And lastly, tangent 8 pi over 17. Tangent 8 pi divided by 17. This is 10.792. All right, great. That takes care of the first half. Got a bunch of things with trig functions, some things with radian measure, degree measure. Now I'm ready to go to the back side where we're going to look at sets and using permutations and combinations. All right, the back side. Numbers 19, 20, 21, and 22 use the following sets. Set A is 1, 2, 4, 7. So it's got 4 elements in it. Those elements are 1, 2, 4, and 7. Set B has 4 elements as well. Those are 1, 2, 3, and 5. And set C has 4 elements, 4, 7, 8, and 9. I want to answer the following. What is A? And then I've got this upside down U, B. Well, this upside down U means intersect. Okay, what does A intersect B? Now think of an intersection for a road. Okay, I'm going to draw a road here, and then another road here. The intersection is where those roads meet, or in other words, the space that occupies both roads. So when I'm talking about intersections of sets then, this is going to be the elements that are in both sets. So A intersect B, I'm going to look at A and B and go, I've got a 1 in both, and I've got a 2 in both. So A intersect B is 1, 2. And I'm going to write that in set notation, so I've got little squiggly brackets here, and then separate my elements with commas. What is A intersect C? So now I'm looking at A and C, and they both have a 4 and a 7. So this will be the set 4, 7. Whereas 21 and 22 have a right side up U. That means union. Union is to take all of the things in A, all of the things in B, and combine it together into one big set. Okay, it's kind of like if you form a union with your partner, the things that you have now, partially belong to your partner, and the things that your partner has now partially belong to you. So it's kind of like one big set. We've got everything all together. So A union B, I want to look at all the things in A, all the things in B, and I've got 1 and 2. Now, I only have to write those once, even though they appear in both. So I've got 1, 2, and then 3, 4, 5, and 7. And then I'm going to do the same thing for A and C. So A union C. That's 1, 2, 4, 7, and then 4, 7, 8, 9. The 4 and the 7, those do intersect, but I only have to write those once. So the set 1, 2, 4, 7, 8, and 9. All right, now 23, 24, and 25 use permutations and combinations to solve the following. So number 23 says 7 people are on a committee. From those on the committee, 3 will be chosen for the positions president, vice president, and treasurer. How many ways can 3 positions be filled? So there's a few things I want to identify. Number 1, how many total things, or in this case, people, are there? Okay, there are 7 total people. Next, how many of those total people will be selected? So 3 will be chosen. So there are 3 that are selected. And lastly, I want to know if the order in which they're selected matters. Another way to think of this is what's happening, the result of this, is it different or are they the same? So in this case, these roles, do they all have the same roles and responsibilities, or are they different roles and therefore they've got different responsibilities? Well, 3 will be chosen for the positions president, vice president, and treasurer. These are different roles. And if they are different, then this is a permutation. Because being selected first, assuming that they're choosing randomly, being selected first is different than being selected second. Let's say the first person selected is president and the second person is vice president. Well, in that case, I would much rather be president. I'd rather be selected first. Being president means you've got a little more authority. Vice president means that you're still kind of having to have this president person in front of you, ahead of you. They've got more authority, more responsibility than you. So order matters here in terms of who's getting selected. This is, again, assuming that they're just selecting randomly. So this is a permutation because the roles are different. Okay, so what does this tell me? This is going to be 7p3. Okay, we're assuming that the roles, you can't be the same, can't pick the same person for president and vice president. So this permutation is going to use n factorial over n minus r. factorial. N is your first number, that's the total, and R is the second number, that is how many of the total are selected. So in this case, this will be 7 factorial over 3, so 7 minus 3 factorial. So this is 7 factorial over 4 factorial. In other words, 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1. That's what factorial means. Start with that number, multiply by every integer down to 1. So 4s divide out 3s, 2s, and 1s. You're left with 7 times 6 times 5. So there are 210 different ways to select president, vice president, and treasurer just from having 7 people on a committee. Now, this wasn't so bad, writing out 7 factorial over 4 factorial. However, when we get to number 24, we'll notice that instead of 7 total people, we've got 28 people are entered into a raffle. So 28 total people, and 5 winners will be selected at random. So 5 of these are going to get selected. Each of the winners will get a $20 gift certificate to a restaurant. How many different ways can 5 winners be chosen? So again, I want to be asking, is this a permutation or is this a combination? If it is a permutation, then each person selected is getting something different or is awarded something different. Here in 23, they were each getting a different role: president, vice president, treasurer. But in 24, they're all getting the same thing. Whether you're selected first, second, third, fourth, or fifth, you're going to get a $20 gift card. So it doesn't matter whether you're selected first or you're selected fifth. So this is a combination. To make this a permutation, it would have to be something like each winner will get a gift card. First person will get a $50 gift card, and the second person will get a $40 gift card, and the third person $30, fourth $20, and the fifth person will just get a $10 gift card. Well, in that case, if they're different amounts, I would much rather be selected first in order to get the largest gift card. So having them all the same, this is a combination. Where you've got 28. Since it's a combination, C 5. So for combinations, this is n factorial over r factorial, and then n minus r factorial. Which for this problem would be 28 factorial over 5 factorial, and then 28 minus 5 factorial, which is the same as 28 factorial over 5 factorial, 23 factorial. And then you realize how many things you're going to have to write down and multiply. This would be, just for the top part, 28 times 27 times 26 times 25 times 24 times 23 times 22, all the way down to 1. And when you've got, 7 factorial over 4 factorial, that's not too bad. But here, I want something that's going to be a little faster. So I'm going to use my calculator. So here's how you do this, whether it's permutations or combinations. Put in your first number. So let's do 23 again, using the calculator. Put in your first number, 7, and then hit math. Go over to probability. And then if it's a permutation, you're going to select NPR. If it's a combination, you're going to select number 3, NCR. So this is a permutation for 23. 7P, put in your second number, that's how many are selected, 3. There's your 210. For 24, I've got 28, put in your first number, math, over to probability. This one's a combination, and I am going to select 5 people in this combination. 28C5. This is 98,280. There are 98,280 ways to select 5 winners from just 28. All right, lastly, number 25. You are playing a card game that costs $1.50 to play. If you draw a black card, I'm assuming this is a standard deck of cards, so 52 cards, half of them are red, half of them are black. If you draw a black card, you win $2.25. And if you draw a red card, you win 50 cents. What is the expectation value of this game? Okay, so before we begin, reminder, this is one of those things where you got to be really careful when you go to, whether it's, state fairs or just places that have games like this, because you're going to have someone that's in front there. They're trying to get people to play, and they're going to say, everybody's a winner. Come on and play this game. Everyone goes home with a prize. Everyone's a winner. And that's technically true here. If you drew a black card, you would win $2.25. If you drew a red card, you would win 50 cents. So there is a prize no matter what happens, but that doesn't mean that it's going to be a good game to play, at least, mathematically. So let's try to figure out what, the expectation is. What can I expect each time I play this game? Well, the expectation, the EV of a game, the expectation value of game is equal to the sum of all events values for that game. And now, how do I find the value of an event? Well, the value of an event is equal to the probability of that event times the outcome minus the cost. So the outcome, another way to think of that is the winnings. What do you get when this happens? What do you get when you draw a black card? What do you get when you draw a red card? So there are 2 events here, and the game actually advertises both of them. So we've got the value of black card and the value of red card. To find the value of each, I need to know the probability of these separate events. The probability of getting a black card, this is 1/2. Half the deck are black cards. Same thing with red cards. The other half of the deck are red cards. Now, times outcome minus cost. If I get a black card, I win $2.25. So the outcome is $2.25 minus the cost to play is $1.50. Now, if I get a red card, the outcome, I win 50 cents. That's 0.50 minus, it still cost me $1.50 to play. So if I get a red card, I'm walking away with less money than I started with. So let's find these individual values first. In the calculator, I can do 1/2 and then times 2.25 minus 1.50. That's for getting a black card. This is 0.375. And for the red card, this will be 1/2 times 0.50 and then minus $1.50. This is negative 0.5. Okay, the expectation value for this game is the sum of all events values. Here I've only got 2 events. So I'm going to add these together. And this will tell me the EV of the game, the expectation value of the game. So that plus that, 0.375 plus negative 0.5. This is negative 0.125. In other words, every time I play this game, I'm expecting to lose, on average, about 12.5 cents, 12 to 13 cents. Now, there is no single outcome here that is me losing 12 cents, right? I pay $1.50 to play. I either win $2.25 or I get 50 cents. But this isn't for a single outcome. This is if I were to play 100 times, 1,000 times, a million times, then if I look at the average, I'm going to win some, I'm going to lose some. But the average says that every play, I'm going to lose about 12.5 cents. If the expectation value is positive, that means I would walk away with money. I'd win money. And the last thing to keep in mind is that you might come across problems where they don't necessarily advertise all of the possible outcomes. Here's an example. What if this was a different card game where they said, if you get a spade, so it's still $1.50 to play, if you get a spade, you win $3. If you get a heart, you win $2. And if you get a diamond, you win your $1.50 back. Okay, but they don't mention the fourth suit being clubs. Well, that implies that if you draw a club, you just get nothing. You get $0 back. That's the outcome. So if it doesn't mention an outcome, you have to find what that outcome is, consider it your loss, so your outcome would be 0, and then minus your cost to play, and then calculate the values of all of the outcomes, all of the events, I should say, including the ones that are not necessarily advertised in the game. So hopefully this helps you out. We've got the test coming up. Please study for it. Use this to help you out. If you have questions, please let me know.